I'd like to welcome you all to our fourth Next Practice event as part of the Imperial Enterprises Lab flagship series that looks beyond current day best practice and look at how entrepreneurs and innovators are creating the future in best practice in entrepreneurship. So this one is on data-driven entrepreneurship. We've got a stellar lineup. We have Michael Carliner from Shazam Entertainment, and recently also just took on a position as technologist in residence, I believe, at True Start, which is a retail-focused VC fund. We also have Elin, who is the Fellowship Manager, ASI Data Science, which is a community of very, very clever, normally Imperial PhD students, although I'm sure there's some from Oxford and Cambridge, but yeah, they're not quite as effective, I'm sure. And that get them into large organizations and effectively educate them about data science, and she'll tell you all about that as well. We've got Tim Davey, who is the co-founder of One Fine Stay, a sort of upmarket Airbnb. I hope you don't mind me saying that. It's just about right, isn't it? And is also our entrepreneur in residence at Imperial Enterprise Lab as well, amongst many others who we all actually met this morning, thanks to Bruno Cotter here, who's managing that practitioner network. And if you're interested in knowing more about that, there's some information on our website about it. Sam Ellis, who is a current executive MBA student here, as well as the head of innovation at M&C Saatchi, and they will share some interesting developments, I'm sure, about what they're looking to do in the data science and AI space. And finally, I'd like to hand over to Mark Kennedy, eventually after their 7-minute pitches, as the normal format, who's the director of the KPMG Center for Advanced Analytics at the Business School, and also an associate professor here as well. So he'll be chairing the event, and I'll be humbly handing over in due course. Just a couple of housekeeping issues. There's no planned fire test, so if there is one, please make your way to the nearest exits. And secondly, the event is being filmed, so if you have any objections, that will be going onto YouTube pending clearance from our panel that they haven't said anything outside of Chatham House rules. But it will be filmed, so if you have any objections, please raise your hand and maybe we can place you somewhere where you will be outside of that. Anyway, over to our first speaker. So Michael, I'll pass the reins on to you. And from... Oh, I get the magic button. Yes, you do.
Which one is the one you press?
It's this one here.
That one there. Jolly good. Hello, Imperial. All right, fine, good. Apparently, I'm the warm-up act, and I'm probably going to be speaking somewhat orthogonally to the rest of the speakers because I'm really talking about hardware-y stuff and the mucky real world of flood defenses and biscuit factories. But it's about, really, Internet of Things. And the funding, this is the message, so you can go away after this, really, which is that industrial Internet of Things in businesses and in the environment is going to be very big, but it's going to take a while to happen. As Chris said, I'm a very old programmer. I've been doing this a long time. I started on the Tornado program in the 70s, in fact. That's the aircraft before it became MLC. And I've done a lot of different things and worked into a bunch of different companies. People remember me as the first CTO at Shazam, which is a fairly funky thing to have done, but I've done a lot of things before and since. We're going to talk about the hype around IoT. Does everybody understand what I mean by IoT, Internet of Things? Hands? Yes? No? Mostly. Okay. It's the Internet of Things is small computers in the environment doing stuff and connecting to the wider internet. Something about consumer and industrial IoT, why maybe it's not taking off quite as fast as people said it would, about how IoT is actually deployed, and something about use cases and how you actually get value out of the data you get from IoT. We'll start off with the mandatory stupid growth curve that everybody shows about practically every technology that ever comes about in the last 50 years. This axis is meaningless units, and this is unrealistic timescales here. And so we've covered that now, so you've seen how amazing it's going to be. Really, there's two segments we think about when we talk about the Internet of Things. One is consumer IoT, and actually this afternoon I was looking for the most stupid internet thing that somebody's made. And I think my candidacy goes to one that's actually real and not completely bonkers, which is the internet toothbrush. Right, but there's plenty of stupid things that people are putting together. It really hasn't come together yet as a thing. We're being bombarded with things we should buy that are connected to the internet, but they're mostly in use cases that are nice to haves and are of dubious value. And the consumer is yet to be proven right about to accept these things, but also actually some of the motivation for doing this in terms of companies is the data they can harvest out of people's activities. And by and large, so far, nobody has found very useful things about toothbrushing statistics being fed back by these devices. But on the other hand, we're all getting much more sensitive about the data that we're leaking into big companies. So there's considerable pushback about consumer IoT. Industrial IoT, on the other hand, really does have some pretty solid ROIs. It's partially because actually industrial IoT is not new. We've been doing it for close on 50 years. We called it SCADA then, which was System Control and Monitoring something. I can't remember the rest of the acronym. But fundamentally, this is not new stuff. It's just been incredibly expensive and dominated by very old-fashioned firms up until now. So the industrial IoT revolution is simply that by lowering cost by an order of magnitude, two things happen. One is that use cases that were uneconomic up until now have become feasible and give good payback. So, monitoring nuclear power stations, you had to have it. But now we can push that down to quite small industrial units and get meaningful data out of these things. The other thing is that some of the technologies in terms of wireless and so forth mean that we can now push this kind of technology into places it's never been before, in the middle of farms in the third world, in lots of different places like that. And there's all kinds of other use cases, which I also really call industrial IoT because they're not straight consumer, they're not TVs and stuff like this, about healthcare and the elderly and environmental control. And there's an awful lot of environmental control stuff, and we'll look at the quick use case at the end of this. I've only got 7 minutes, I'm rushing kind of. However, the bad news is that the truth about industrial IoT is this is where what we've got, our usual concept of startups and of the way that technology is adopted is like it's Pokemon Go. You release it, and 3 weeks later, there's 4 million people doing it. However, if you're building a bridge, you're not simply going to build a bridge in 2 weeks simply because there's an enormous amount of technology come down the pike in terms of being able to monitor or do better things. The fundamental life cycles of big infrastructure projects is not going to change just because we've got stuff we want to sell. And this tends to mean that there's this collision of expectation in terms of investment, in terms of the way that people are doing startups, that is going to mean that you're going to need some considerable patience and endurance if you're going to start up in these fields. The other thing that's less obvious is that there are actually few teams and companies which have got all the skills in one place to be able to deliver final solutions for this kind of thing. We're used to the idea that we might work in let's say, a data analysis consultancy where you've got a feed coming in one end and nice visualizations and insights come out the other, and you've got some cloud infrastructure in the middle and project managers and maybe some UX people, and you've got that integrated team. We know how to build those things. And we know how maybe people have been creating interesting bits of hardware or making TVs or stuff like that. And also doing physical design, people like Philips or Sony, something like that. But there are very, very few teams. There's not that kind of education about how you form a team that goes all the way from doing physical design and deployment, logistics, network management out in the field, and telecommunications management, all the way up to data insight. And that's becoming more and more apparent. If you're building, let's say, a ship, or back to my bridge example, the companies, Ove Arup or Maersk, who are building stuff like that, they want a solution. They don't want AI from IBM and maybe a wireless network from Vodafone or whoever, and all their various bits. Everybody in this game at the moment is holding various pieces of the puzzle, but there are very few systems integrators in the old school style, which actually I came from, where they are integrating these things together, and it's even wider than it used to be. So that makes a considerable barrier to the adoption of these things, because there are plenty of companies interested and willing to buy this stuff, but they actually want complete solutions because they've got no way of putting those pieces together. And by and large, there's quite a lot of incompatibility and churn in that business as well. So we're going to be seeing that for quite a long time, and it means that there's going to be tire kicking and prototyping for a long time to come before we start to see the mass deployments that the people like Gartner are telling us will be in the billions. However, there is, even now, real value to be made bringing these things out. And this is my pals at Unify who are doing, admittedly, a pilot at the moment, but it's a real pilot, it's really there, and it's creating real value. Has people here heard of Legionnaires Disease? Anybody? Yes? No? Few? Yeah, right. It killed a bunch of people who happened to belong to some sort of peculiar association called the Legionnaires of something or other. I think it was in Arizona originally. And it's a bacteria that breeds in hot water systems. And it creates a very nasty form of pneumonia that can kill you quite quickly, in fact. And it's not curable, so it's kind of terrifying. And that has caused a reasonable amount of legislation around the world, and specifically here, about monitoring public buildings in case they're harboring this stuff. If you're currently in a public building like a shopping center, hospital, anything where there's a lot of people and typically quite a lot of running water of one description or another, you're going to have engineers running around with thermometers sticking them up taps all over the place. And this really does happen in hospitals, and they're spending a lot of money on this stuff, right? Because you have to keep the water hotter than the temperature it needs to kill the bacteria and lower than what it takes to burn people. And you need to keep those mixings going and monitor that continuously. And you're liable for prosecution if you get an outbreak of Legionella if that happens. So there's real money being spent on this, and people doing real manual, laborious work doing that. In the case of the IoT system we built for this, we're using what's called an LP WAN. So this is a new wireless technology which has got very wide-ranging range. In urban environments, it'll go about 2 kilometers. In open country, it'll go up to 20. But you can run a node with this stuff, which is battery-powered, will run maybe for several years on one set of AA's. So it's much lower power than Wi-Fi or GSM, much cheaper than either, and it's got this ability to punch out through large buildings and things like that. And we're using this in a shopping center in the north of England, and that is being using a conventional time series database, and that's extracting continuous data and giving warnings about if we've got danger of breeding Legionella at any given point. That's a genuine use case. It's being done by a small company. It's got very high value, and it can be rolled out across large sections of this country. There are plenty of other examples like that, which may not be incredibly sexy. They're not to do with enormous insight or advertising or things like this, but they've got really solid ROIs, and they're real use cases that will continue to be valid for many years to come. There are many more in terms of recycling or the environment, flood warnings, healthcare, dementia sufferers, all kinds of things like this, which are very high value and need solutions then. They don't have existing solutions, and they will generate value for companies. Work we're now moving into starts to take the more conventional analytics that we've been using, which is time series databases and charting and stuff like this, and starting to replace them, or at least augment them with putting neural networks, things like recurrent neural networks, which can learn patterns and autonomously work out whether a situation is normal or not normal. In the situations like the previous one, where we're talking about something like this, you're basically setting for each sensor some limit on heat and maximum heat, minimum heat, so forth. And that's easy enough in this situation where we've actually got legislation that tells us what the numbers are. But in the real world, in complex worlds where we're looking at maybe farming or something like that, it's not so easy to know what's the normal situation, what's an abnormal situation. So this is where we start to move into using learning techniques in order to be able to look at many thousands of sensors and make sense of the patterns that make these things, and also use them for prediction or optimization in terms of something as mundane as the routine of picking up bins, recycling bins in urban environments. If we know when things are going to fill up, we don't have to do it every Wednesday. We can do it when things are filled up, or at least when they're likely to start getting smelly. So that's a very sort of quick gallop through the kind of relationship between these new technologies, which enable us to be able to put computers into pretty much everything, including breakfast cereal, and the data that we can really harvest on it, off them, and the value of that as well. Thanks.
Take questions now, or they take questions afterwards?
Hi everyone, so my name is Elin. I have a very different background from Michael. I started in finance and I moved into technology, working in data with various different startups. And now I'm working for a company called ASI Data Science. So very quick introduction. So ASI is a data science consultancy and software company. The bit that I'm most involved in has been the fellowship and education component, which is working with the top PhDs and postdocs from STEM backgrounds in universities in the UK and Europe and the US, and helping them move into industry, whilst on the other side advising the companies about how to do data science, do projects, transform themselves, recruit good people, and so on. So I've put a selection of clients, not to actually show off about which clients we work for, but much more just to show the breadth of companies that are now involved in data science. Because people are always asking, oh, who's doing what, what's interesting? And the truth is there's just too much to mention. So we work with startups that are 5 people who are super focused on one particular use case, all the way up to your BBCs and NHSs and Tesco's who are absolutely massive and could probably use data science in 1,000 different components of their business. So one of the things that I now do a lot of is called data transformation. And what that means is actually helping companies actually use machine learning and make it useful for their business. So when people think of data science, they think the tricky bit is building the algorithm. And that is just not true. The algorithm, if it takes even 25–30% of the time, that's probably already an overestimate. To actually make data science work is having good data scientists, but just as important, having really good systems to collect the data, to be able to productionalize anything you want to do, which is now called data engineering or machine learning engineering, as well as traditional software engineering. You then need to implement in your business. You have to design or change your systems and then change processes, which involves changing people's workflows and then changing the culture. Every single one of these components takes absolutely ages. It is not the case of having an algorithm and then today saving lots and lots of money or making lots of new money. And so a view of what kind of stuff we do, it's a bit of everything really. A lot of these are buzzwords. Obviously you've heard you can use data science to recognize images, to process natural language, to look for anomalies, predict various different things. Anywhere where you collect enough data, we can probably do data science, but whether that actually adds value to your business or not, that's a different story. So when I think about much more, it's more what business units require what kind of data science projects. So these are a kind of a section of the main stuff we do. Obviously marketing, as you probably have been victim of already, lots of companies' marketing strategies using data, and that could be anything really. It could be selling you more stuff, upselling you, understanding you, giving you personalized recommendations, following you around the internet, emailing you at the exact right time so that you react better. There is optimization across all of marketing. And we're going to give some examples later, which are hopefully a little bit cooler than just bombarding you with emails. And then risk is a huge one, just because finance has always been one of the pioneers of actually using data. So quant finance probably came about in the 80s. And now lots more companies, even in finance, are thinking of actually using data science. But it doesn't mean that they haven't been using numbers pretty successfully for the last 30 years. Logistics is a really exciting one. And that one is still pretty new. There are your Amazons who have been optimizing logistics for a long time, or at least a couple of years. But actually now we're speaking to more traditional companies like energy, transportation companies who want to optimize where their things go, or predictive maintenance, or routing, these kind of things that have traditionally not been done with machine learning. Sales and people is a really interesting one. So an example is like a startup we're recently speaking to who have a platform that as you speak and make your sales calls, they recognize the words and the kind of tones, and then try and help you in live time change your behavior to make it a more successful sale. I mean, this kind of stuff is really new, really exciting, and hasn't been around much. And then the other is extremely broad. I mean, we work with charities who want to understand the impact of the work that they're doing on like news portals. We work with museums on like modeling visitors flows across their museum to avoid overcrowding. It is as broad as you can possibly imagine. So I'm going to give a couple examples now of projects that very big companies are doing, but also apart from the machine learning, what kind of like impact they can actually add to the business or not, and the problems that they can face. So here is a very nice fancy chart, which is always the goal of any consulting project, or not. So this is work we did for an airline. So airlines, notorious business models, really low margins. And one of the reasons for this is because when things go right, they don't make a lot of money. As soon as things go wrong, they lose loads of money. So avoiding things going wrong is a core part of their business. So they will have lots of staff on standby, because if there's not enough staff, then the plane can't fly, they lose lots of money. But actually, how much staff should you have at what point in time, at which airport, on which plane, on which route, what time of the day, what month? This is a data science problem, which then becomes a machine learning problem. And so run that through your models, and what you get is, instead of having to, you basically just about half the number of staff you need to have on standby across all the different airports in your network on every single day. So this is machine learning. It looks really cool. It saves you lots of money on paper. But actually, implementation of this takes a really long time, partially because of the systems and even culturally kind of building trust that doing this does not massively affect the bottom line, but also more just people, labor, laws, different countries, different systems. Like a model which takes 6 weeks or 8 weeks to build could easily take a year to implement and still not implement fully. Here's a slightly more optimistic one, which is predicting long-term value. So when you want to run a campaign, right now, what people are focused on is how many customers came through. And then at some point in the future, once you measure how important your customers are, you know what the lifetime value of that cohort is. But actually, for retailers who have a lot of data coming through because they're things that people go to often, in which case is a supermarket, you can actually predict to pretty good accuracy who your high spenders are going to be within a couple of days them signing up. And then you can start tweaking your marketing campaigns. And this is a more impressive problem than it looks, because the high spenders is actually a much smaller class than the low spenders. So if this was about predicting who are likely to be low spenders, the numbers are more like 80, 90%. This is a nice example because it's very actionable. And when we do this kind of work for clients, they start implementing it next week or next month, and they start changing their campaigns. Another one that people were excited about, because this is a bit to do with IoT, is this is tracking people through a supermarket. And as they kind of walk through different parts of the supermarket on their shopping trip, their behavior, how much time they spend, and so on. This looks like a mess, but again, actually, you can break it down to a data science problem. It's kind of the time they spend, which areas they go into. You do lots of fancy techniques, hierarchical clustering being one of them. You see how different their paths are. So this is great. We did loads of work on this. But now what? So you've taken this, you understand where your customers walk through, but it doesn't, you have to change the layout of your supermarket. Do you change the offers you send people? Do you change what products you have? Again, this is 6 weeks of modeling work, but who knows how long to actually make this happen and implement it. And then a last one, which I think probably ends on a positive note, is product categorization. So retailer, lots of different products, you put them in the right category so they can be found on your website. This is a very manual process for almost everyone. It sounds like a data science problem. It is a data science problem. But the reason you can only get to 70% accuracy is because a lot of the products have already been categorized incorrectly over the last X number of years. You have a lot of duplicate classes that categories, which it's not even obvious to a human which category something should fall on. Your model's only going to be as good as your data. And it will take although you can run this now, and this is great, and it supports the people and saves them a lot of time, it will take quite a long time to clean up the data over time to be able to make this incredibly accurate. So the last question Chris asked me to cover was, so what does this mean for people who want to be entrepreneurs in this space? Well, no easy answer, but this is a great company to use as an example because they are a subscription service, personal styling service for clothes. Sounds like a very standard business, except that they have 80 data scientists in what is actually a relatively small, scale up in startup world. And one thing which I was really impressed with what they did was that they really just have applied data science to absolutely every aspect. If you think back a couple of slides where I had all of the things that one could do with data science, they're doing pretty much all of it. And so the only advice I can give to entrepreneurs today is that regardless of whether you're going to run this data-driven business or just a normal business, it's trying to be really smart from the beginning about the data and optimizing all of the different components.
Thank you. Hello, so I'm Sam Ellis, I'm Head of Innovation at M&C Saatchi. If you don't mind, I'm probably going to aim more over this way because I'm also a current student here and I can see some of my fellow hello who might heckle, so I'll probably face more this way. So as well as looking after innovation for M&C Saatchi, I also look after a small angel investment fund. We've invested in things like Graze.com, Tails.com, so primarily subscription businesses, and also Talent Spot for our Saatchi Invest Fund as well. So they make me put that so we can get past that. So Chris gave me this quote by Tyler Cohen, and it said, the better individuals become at working alongside machines, the more the economy of tomorrow will reward them. So I've got 7 minutes and 30 slides, and hopefully me and PowerPoint together can kind of get a bit better. So let's go. So first I'm just going to talk about a little bit about us and the industry and what we're working in. So I work for these guys, so Morris and Charles. Charles not involved so much, and it's M&C Saatchi, not Saatchi and Saatchi. There's a lot of confusion between the two, but I work for the Saatchis that have the Saatchis, so that's always a good start. So we work on this principle of brutal simplicity of thought, which allows, there's lots of different things we could do in the world, and we're always trying to make things a lot simpler. Okay, so that's our kind of defining philosophy on everything we do. So we work on, I would say, issues of national importance. You may know some of this work, you may not know some of this work, you might like some of this, you might hate some of this, but whatever you do think about it, this work exists in the world, and we work on some quite big, important things. But the reality is, we don't really know what advertising is going to look like, and anyone that says they do know is a liar, because I know we certainly don't, and everyone I talk to says the whole industry is changing so much that it's tough to keep pace with it about what's really going on. And the reality is, if you think about us as a group, we do all kinds of different things, and bluntly, we are under assault from a huge number of different companies, whether that's strategic consultancies, whether that's big data consultancies, a whole different ways, loads of different ways you could do creative, internal companies, so people like Spark 44, that's Jaguar Land Rover, they've created their own agency. Big tech companies, production companies, people like Facebook, delivery companies, we are under assault, and we're trying to think about what on earth do we do about this in this incredible world of data. But the reality is, so where we're going is, it's not really about making ads anymore. We kind of work on the presumption that what we need to be doing is about creating impact in the world. So the kind of 3 businesses that we are working on at the moment, to give you a sneak peek, are really focused on finding you, knowing you, and being tailored to you. And we are restructuring our whole business around these 3 pillars. So what about opportunities for data-driven strategies, tools, and techniques? So this is some stuff we're using right now, so I thought it would be interesting for people to actually understand the kind of things we work on. So I think the first thing is, from HBI, 11% of marketers relying on data for only 11% of their customer-related decisions. In the industry, people are still not using data in the way they actually should be. So they're relying on previous experiences, intuition, one-off customer interactions, conversation with colleagues. And there's this explosion of data, whether all of it's useful or not. Completely agree with your point. A lot of it's nonsense, but there is a lot more of it. but actually it's our ability to process it that's making things a lot more interesting. So the kind of areas we're looking at, so we're doing a lot more stuff around vision-based marketing, so things to increase operational efficiency. We're doing a lot of stuff with language-driven AI to improve customer relationships, anticipation and decision-making to increase sales, and insights and discoveries to optimize marketing spend. So I'm just going to talk you through a few things that exist that we're using at the moment. So the first one is Segment. I don't know if anyone's heard of Segment. Segment's a brilliant tool. If you're a startup and you want to get involved in marketing, basically what Segment do is they collect all of your customer data from every single different channel, put it in a place that you can access it with some brilliant APIs and some amazing integrations into loads of different platforms. So if you're a startup today, go and spend some money on this. It's absolutely brilliant. The next is we're doing some amazing work with IBM with predictive customer intelligence. The IBM team have been absolutely fantastic using their Watson machine learning system. A company called Intent HQ, big, huge supplier to O2. And so what they're doing is using loads of different customer data points to build profiles about people so that they can market to you better. We're also working with a company called Picasso Labs, and what they're doing is really data-driven AI-powered recommendations about really what creative is actually working for you on social. So rather than having subjective conversations about, I like this picture and this combination of words, we're actually getting real-life proof at scale. SpongeCell, absolutely brilliant creative management platform, and what that does is it essentially brings together loads of different creative assets with incredible programmatic media, so we can essentially optimize on the fly as we go through. Phrasey is an incredible tool that's actually generating emails for people using AI, particularly optimizing and amending subject lines as they go through. So really, really clever, really cheap bit of tech, and a brilliant British company. So that's some kind of stuff we're doing at the moment. I just want to talk through quickly about our future focus. So we're doing a lot of stuff around conversational user interfaces and creative origination using AI. So the first one is around, there's a reality, and I don't know if you've seen this chart, but it's been going around our industry for a while now. And it's just, what it shows is the big four messaging apps have actually overtaken usage for the big four social networks. So WhatsApp, WeChat, and Facebook Messenger are now more popular than Facebook and Twitter and LinkedIn and all of these things. So Instant Messenger is actually now most people's primary social platform. It's the place people are spending most of their time with on their phone. But the problem is you can only really get into those via chatbots. And even then, WhatsApp is still impenetrable, but Facebook Messenger have opened it up now. So businesses can get involved in these environments, but only via something called a chatbot. And what those are computer programs that can mimic conversation with people using AI. It's a pretty loose definition. It's a lot more complicated than that, but these chatbots are now becoming much more popular. A lot of them are not very good at the moment, but they're really, really interesting. And simply because you can start to do some really clever stuff. So people are starting to use them in very interesting ways all around their customer journey, and essentially centralizing a load of different conversational data and giving you insights across a customer journey. And they're really interesting. They're input and output agnostic. So it might start with a text message, you might start with email, but then you can output into all kinds of different channels. But also start to use things like voice assistants like Alexa and Google Home. And an interesting thing we're dealing with a lot of our clients at the moment is, how are you going to market to Alexa? I know with my Amazon Alexa, when I say, can I get a cab, it's defaulted to Uber. So well done, Uber, for getting on the Alexa. How is anyone going to get that off my Alexa? So if you become the default app on here, you win. So that's something we're telling a lot of our brands to consider. The next one I think is really, really interesting. I think this came out of a big pitch I worked on about 10 years ago now. And Christian Purse, who I was working with, he's now CEO of Interbrand, and we were drunk and we just seen a load of creative work. And the creative director had said, it's absolutely brilliant. It's going to be the best work ever, and it's better than anything we've done before. And he sort of drunkenly said, our creative director doesn't know if that's good work, and she can't remember all of the brilliant work that came before it. Simply, the human brain does not have the capacity to know all of these things. So what we're trying to do is use AI to actually create advertising. And a lot of people are saying that this can't be done, and so far I think we're starting to say, yes, it's terrible at the moment. In Japan, people are using crap robots to draw Japanese characters and say it's advertising, which isn't great. In the Netherlands, people are using them to redraw and create new Rembrandts, which we think is a bit more interesting. We've done some work. So this is a poster on Oxford Street. At the top is a Connect camera. And what it does is people are looking at that poster and they're engaging with it. And what it's got behind it, we've got a genetic algorithm that's evolving basically different copy lines, different imagery to create basically the perfect ad that people are engaging with. And it's using that over time. We've only just taken it down. And so where we're going with that next is we're using generative adversarial networks, which basically compete against each other, which is a really, really interesting area of AI. We've got a huge database of previous and very successful advertising. And what we're actually doing is combining the two to actually create some really interesting, very, very quick, very effective, hyper-personalised and relevant advertising, but very quickly and at a very low cost. It's certainly not going to be challenging many creative directors for a while, but for a smaller business, it's definitely a really interesting area. So we're creating companies in these two areas. But I think if there was going to be a conclusion, I think I've just got there. 1 minute left, there we go. All of this clever stuff, people are still making shit ads. Okay, so it doesn't matter how much data we've got, doesn't matter how much insight we've got, somebody's still going to come up with clangers like this. So be careful. Okay.
It's good, I enjoyed that. I'm going to be probably the polar opposite. I think we've got about 5 slides. So it's going to be a little slower. And I dovetail a lot on what Elin said. I'm focusing more on the operational side, but I'll go into that in a second. So a bit about me, yep, Imperial alum, as it says, 2008, there you go. And then just started here as an entrepreneur in residence, as mentioned before as well. And as a co-founder of One Fine Stay, I was also CTO, and I've done a couple of other businesses as well, YC businesses, that sort of thing. So my area of expertise is definitely in the technology realm. But yeah, let's talk a bit about One Fine Stay. So what is One Fine Stay? So yes, high-end Airbnb. But what most people don't realize or don't necessarily know is that to make that, what that means is we ended up creating a distributed hotel. So we did the full stack. So we did all the servicing, all the rest of it, which meant we ended up being one of the largest cleaning businesses in London, one of the largest plumbing businesses in London, because guess what? If a boiler breaks, you can't necessarily rely on the landlord to go fix that, right? Like if it's a high-end service, you're at the end of the line, so you're the one who's got to go and like fix it. But the interesting thing about us and why it's like related to data is data is like the core of our business, and I think it's true of any modern business that data really should be at the core of the business, and that's why we differentiated. So like a lot of people go, oh, it's a great idea, and Airbnb, oh, it's a great idea. Actually, no, both our businesses were like just like really well executed. Airbnb, fucking amazingly well executed. But with us, it was around. There's a lot of businesses out there who do like villa rentals, this sort of stuff, right? Like everyone's heard of Home Away and these other businesses which were around. Like this is one of the oldest industries that there is. You just go and stay in someone's home, and then they became professionalized. And so what we had, which was very different, is that we decided to build like a technology platform at the base of it, where all our decisions, and this is where data and how we consider it to be slightly different, is around a lot of what we've heard today and a lot of which we hear about the new like data revolution. It's about volume of data and what you can do with that data in terms of, so marketing, for instance, and how you implement it. But if you're building a business from the ground up and you say, right, we're not really going to make, you're going to make most of your decisions based on the data itself. So an Uber is a good example. So for instance, at any one time, compared to a traditional dispatch, a taxi dispatch, that would go via a human who would make the decision about which taxi it should go to next. But with us, for instance, and with Uber, all of their decisions are just made autonomously. And if you buy into that, you have to buy into it wholesale. And I'll describe how that kind of works in a second. The other big thing about us and kind of what I'll talk about is a lot of like the data revolution is about kind of big data and voluminous data and taking very messy data and trying to solidify and make that more intelligent. And you can do that with algorithms, but you can also do it with process logistics and people as well and just like clean it up over time. So that's more the approach I'm going to take here. So we did a lot of like the cool, sexy stuff where we analyzed like how many search queries are coming in particular areas and like how much demand and ebbs and flows we were going to have. We did some of the customer segmentation stuff where you're looking at how much money each individual people are spending and what kind of cohorts. Are they romantic couples going to Paris, or are they like big families staying for 6 months because one of the family is on secondment because they're like CFO Apple or something like that. So yeah, so we did a lot of that stuff, but I find that almost less interesting because so many people are doing it, and I guess it's so well talked about. So that's why I wanted to talk more about this. So this is our kind of like a brief overview of the engine which we ran our business on. And it looks relatively simple, but it meant that we could do a lot with it. So at its core, we had like a brain. Now most companies would have this as like individual people, but like if you think about our business as 2 kind of form factors. So the first factor is we're a bookings company. The second factor is we're effectively we're a property management business at the core of it. And it was actually like a part of vision which we may, probably unlikely to go into now, but which we're potentially going to move into, is that if you're looking after somebody's home, so for instance, if a guest is in stay and the boiler breaks and we're well suited, we've got a panel of plumbers to go and fix that, then why wouldn't we also do it during in-stay as well? So this was at the core of the business. We always thought, how do we make a system that's reactive to both bookings, but also reactive to any kind of input that ends up going into the system? And we'd have this brain in the middle, which is like a big process and working engine, which we ended up building ourselves, to then go and do really smart stuff like, so we started doing like this gig economy stuff and rostering. So a good example of these two is same as standby times, right? So on any one day, we've got a couple of hundred cleaners going about London, going and cleaning homes, right? And so how best do you do that? So at certain times, we have peaks and troughs like any business. So on an Easter weekend, for instance, we know we're going to have a spike. We don't necessarily know how big that spike's going to be. And so what we wanted to do is similar to the grid, what you want to have, so you've got, like at any one time, you've got certain predictable spikes that at 6 p.m., all the kettles turn on, and then you've got to then release like electric dams, you've got to pump up nuclear power, and that sort of thing, because not nuclear power, the opposite. So you use like coal in the most of the time, then you use gas, there you go, thanks. Anyway, so we started to do that with people. And so, because it's not just one group of people that we were dealing with, right? We were dealing with our standard roster of cleaners, which were on our books. So we had on our books all the rest of it. But we also had all the plumbers, all the handymen, all the rest of it. But we also then wanted to be able to go, OK, at any one time, we want to be responsive, but also predictive, so that we could get slightly more expensive, like gig economy workers coming onto the system. Because that's the difficulty with like both sides, is again, the implementation is really tough. Like you can have all this data about how predictable it is to get someone, or how many people you're going to need. But actually implementing that's really, really, really hard, because so let's say the summer comes around and we suddenly have loads more guests coming to stay. That means we have to hire in like 200 cleaners or whatever it is in a couple of weeks. But you got to hire them, which takes a lot of time, like making sure that these people are good, they're going to turn up on time. But also then you've got to train them, because I mean these people may have had training within hospitality situation, but trying to do like what they need to do in a home is a completely different situation. And so enacting on that data is really tough. And so that's why if you've got a system that's a lot more responsive and you're building the whole company around this system, then it allows you to start making decisions in a far more automated way and rather than a centralized way, which means you can eventually start scaling out, which is what we ended up doing. We started to scale that to the 5 cities, but now over the next couple of years, we can then start rolling out to 40 cities. But the limiting factor to our business wasn't necessarily the data. It was the fact that we didn't have the people on the ground. We didn't have the logistics infrastructure in place, which is, so we got bought by a hotel chain called Accor, and they have that logistics base and that infrastructure already in place, which meant they can now utilize this big data platform under the hood to then go and roll it out as fast as possible. Yeah, it means you can do these things. So this is something that sits under the hood. So a good example is about the complexity of data. So what we ended up doing, so this is a snapshot of something called the Ontology. And so basically what it was is a big graph database of, we ended up having like a graph database for every single home. Because like, imagine it, right? Like every time somebody goes into a home, they've got to be able to clean it, but it's like the first time they've been into the home. Like if you've ever had cleaners and you've had like a new cleaner, you've got to sit down, you've got to talk them through it, and it's kind of like, okay, where does all this stuff go? And especially if you're provisioning it, so what we did is you provision it ready for a guest, and then you provision it back ready for a host. But how annoying would it be if your shampoos, which were like you keep on like the second shelf in the bathroom, you've got to put them away because we're going to put in our own shampoos. You don't want to be using somebody else's shampoos, right? So you've got to take all that, you've got to tidy it away somewhere, put it in a nice steel bag, got a QR code on it so you can track it, hide that away somewhere. Then what do you do when it comes back round when it's a completely different person who does that? But even if it's the same person, they wouldn't remember anyway. So how would you do that? So that's why we built this thing. And so basically it's a description of the entire home. And what you can do with that is then you can start just like piecing like nodes associated with it or stuff associated with the nodes. So with each of these, you can start, so it would power the website listing. So you've got this like big, gnarly database. Then it compiles it down and makes it really simple and beautiful with like loads of beautiful photography. And it makes a really lovely view of the home. We also, for instance, like how-tos of stuff. So like I think it was like 80% of our calls are people going, hey, the TV's broken and it's like I don't really know how to use it or something like that. So what we started to do is, again, if you've got a system like this, and we ended up, like, I think we probably do have the biggest database of just appliance manuals there are. Because it's kind of like, if you go and gather that once, you don't want to do it again for every single home. So again, if you've got this really, really deep database of this information, then you can start to leverage it across all your homes. So that's the second bit. Third bit, handyman. So again, if you know that one particular boiler has got like some weird issue, if you've logged that once, again, it just makes it so much easier when somebody calls up, be like, okay, yeah, we know what to do because this handyman's fixed it these 4 times. Or again, if a handyman goes in, knowing where the stopcock is in like a water stopcock in the home, like again, really obscure thing, but it's something you have to track. And it means you can go off there. And then analysis. So I think if I got it, I've got it here. Yeah, so analysis going back to kind of like proactive stuff. So a big difficulty and like a huge amount of variance which we had, and an important part of the scheduling the people, so if you think back here, right? If you're scheduling people to go around all these different homes, depending on the cities, that was a real difficulty for us. So London, for instance, lends itself that we've got like a relatively good transport network. However, in, say, LA, there just is no transport network. And so all your cleaners like have to drive around, and that's fine. But in London, like the best way to get around is not in like a car by itself, because you've got nowhere to park. And so the cleaners have got to go from place to place via public transport. But what about all their supplies? So how do you get like towels and stuff like that for the entire day? That's a really awkward and hard thing to do. So that's like the first challenge, right? And so what we ended up doing in London is that we send round a van which goes and drops off the stuff at the exact time which the cleaners end up getting there. But there's also other complications. If you want to utilize, so one, you want to make sure that the cleaners are traveling in the lowest possible radius that they can, number one. And then number two, you want to try and keep them as close together as a team as possible. Because if you've got 3 people, then 2 people, then all of a sudden, where's that one person going to go? Is he going to go join another team somewhere else? But if that's the case, those teams have got to be synced up. So if you have good analysis about how long it's going to take in the home, whereas, you know, if for instance there's kids in the home, or if there's like 20 bedrooms or particular like nuances of the home where you know that there's like a lot of issues with it, then you can far more accurately predict how long this stuff's going to take. So a good example here is what we did is the seals are like, we seal off a part of a cupboard. So it's like, you know, it's called tamper tape, and you often see it on the tube. If you peel it off, half of it's still left on, you can see it goes void. So we use that in people's homes. And what you can see here is like, this was a really good example where we could also benchmark across cities. So these are, I think this is the number of seals per room, and then this was LA, this was London, and this was Paris. And the really interesting thing here is you can see that like they use different amounts. And so we could then like, not only is it a good measure for optimizing our business, but it's also a really good measure for benchmarking our business. Because we could see here the operations team were acting completely different to the LA team, where the LA team were just like, oh, we'll just put them in like in way more relaxed. But in Paris, for instance, people were way more protective about their belongings, or so we thought. It was just the Paris team were proactively adding more things because the team themselves are a bit more bureaucratic in the way they're thinking about it. But we were able to coach the Paris team to be a bit more like chilled out and more LA, which meant that saved massive savings in the long run. And then the final thing here, which I was going to say, is what you can also do then is when you have really good analysis about how long something's going to take, you can also start to do stuff on the fly. So for instance, you can start pushing in new tasks, like replace a light bulb proactively, but that's not necessarily something that has to be done. Then you can do stuff like sealing the cupboard, and then you can do the most important part and probably the most the biggest bit about this with the complexity of data is if you're going to be relying on this data, unlike if you're doing like a marketing like campaign, or you're doing like reactive analysis where you're thinking a bit more strategically. If you're making day-to-day operational decisions on this, then you've got to make sure you're recollecting that data. So my point here is you can use processes and people to make sure your data is fresh. That's it.
The chairs, and while we're doing that, I'd just like to invite you all to log into menti.com. So there's a link here. There's a question every time we run this. It's quite interactive. We want to hear your opinions on where there's the greatest area for disruption. So please log in with your iPhone, plug in that code. It's a series of questions, but I guarantee it will eventually reach the one that we're after, which is here. So do please answer away. And I will now hand over to Professor Mark Kennedy, who will chair the Q&A.
Great. So as I understand it, Chris, you want me to ask a few questions and then open up to the room, is that it? That's right. Okay. So I've taken some notes of some things that might get us started into a bit of conversation. We'll make this brief and then we'll open it up to the whole room so everybody has a chance to jump in. I suppose if it's all right, I'll just be boring and kind of go in order. I'll ask you each a question that's kind of related to what you spoke about, but try to weave a theme from it. What was interesting, Mike, about your stuff is that you talked, as you said, more about hardware than anybody else. So I suppose to sort of a broad audience of people, some of whom are going to be really smart about this and some of whom are just getting really smart about it, what would you say the rest of the world is kind of missing in terms of understanding how, as we start to do these things, and it doesn't just have to be IoT, it could be sort of a broader variety of applications that have to do with all data and analytics, what should we be paying attention to that has to do with hardware, not just data, that we might be missing?
Actually, I think it's both specific to the intrusion of hardware, internet-enabled hardware in our lives, but it also spills out into pretty much everything else, and I think it's ethics. And I tell everybody that I'm mentoring at this point who's starting stuff to start with a code of conduct, because it's very easy to lose sight of the fact that there's people out there that we're connecting this stuff up with. And I mean, Samsung are a great example, who have their TVs listening to us. But you do that because you're not thinking, and because it's not a pervasive thing within the company to really think about the ethics of putting equipment intimately in contact with people's lives. And there was a certain intimately, very intimate piece of gear recently that is being sued for hundreds of millions because it was actually reporting people's sexual habits back to the manufacturers. And that is not just unethical, but it's not thinking. And ethics is not just about being nice to people, it's about not being put out of business. And Uber seems to be a case in point at this point. And the hardware we're putting in is especially intrusive. It's intimately connected with our lives, and it's not visible and obvious like a laptop or a mobile. So I think that's the thing that people aren't getting so much.
Okay, I'm going to keep rolling with that because it's provocative. So, Elin, you gave us a list of horizontals and verticals that you guys get involved with. As you think down the list of horizontals and then verticals, where in that list would you say is sort of the most, let's say, opportunity for improvement in terms of taking Mike's point on board?
So slightly tangential. So on the fellowship, we obviously teach a course of like how to be a great data scientist. And one of the things we actually introduced was ethics in data science on the last cohort, and we're kind of expanding upon that for the next one. Just because it is something that people haven't thought about because they got caught up in the excitement. In the same way, for productionalization, you get lost in the excitement of seeing these really beautiful models. And actually, as a data scientist, almost everything you do will have ramifications. So obvious ones are, we have all these laws about discrimination. And if I predict how, how high value Sam is going to be as a customer based on all of these other data points that I've collected. Actually, how many of them am I allowed to use and how many of them I not? How many of them are intrusive? How many of them break laws? And I think there's finally, in the last 6 months, there's now more talk about this. It isn't just about AI replacing our jobs. It's when the power of like decision making on things that really matter, whether you're going to get benefits or which drug treatment you get, or so on and so forth, start being automated. Have the people behind it actually thought about the consequences and the different use cases? And this is especially very prevalent, say, in government in the US. It's been talked about a lot because the I suppose like institutions have outsourced the algorithms to other companies like consultancies or software companies, and therefore no one actually knows what's going on inside the box. These are just assumptions, but these are algorithms that have a huge real-world impact on people's lives, and so it's something that we're now pushing a lot to try to get people to think about stuff before they decide to just make these like decisions on their assumptions.
Okay, very cool. And Sam, so you put us onto warnings about Candy Crush, which I suppose touches on this theme as well. If you broaden out from the kind of potentially sinister implications of different apps kind of tracking us in ways that we aren't aware of, which was your point with them. By the way, I think I'm the only like dork in the room that admitted to having this, which is mostly on my iPad, so I don't know if that helps me or not. But you guys are generating in part, among a lot of different things that you're doing, creative content. Does it matter to people that you would sell that service to that they know that it's done that way? Do you make that clear? How does that sort of fit as an issue into this general question of where is all this coming from? What's the provenance of either data or, in this case, creative that's produced by data?
I just want to see where this was going. I was like, shit, ethics and advertising and data. It's like, I'm fucked. So I think there's a couple of things. I think the example I always use is Google Maps. How many people here use Google Maps? All right. How many people here use the traffic function in Google Maps or use Waze? Like, how useful is that aggregated data? You've signed up for that. It's really useful, and there's a lot of stuff out there that's really useful. Another great example, again, on iPhone. There's location services on iPhone. Has the option of, there used to be 3 options, okay? It was turn it off while using the app, turn on location services for every app. If you go in and have a look now on location services, Apple offer all 3 of those options, but they just decided when people, most brands have decided to give you off or on. They've made it binary. And the reason is most people are turning these things on because actually that aggregated data is useful, okay? I think there's a lot of stuff, and what I find quite interesting is we actually spend more time advising brands to not do things than advise brands to do things. It's often a lot of the brands, a lot of the clients we work with, they're the ones that are actually taking things quite far, which we're finding really interesting. We kind of assumed we go in and say, here's all this cool stuff we can do, and they're like, yeah, we're doing that, and we're saying, actually, do you know some of this is not legal? There's things like, you need to really row back on this, things like GDPR and stuff. There's some incredible data legislation that's coming through that a lot of brands are just not aware of. So I think my personal view has always been that a lot of advertising is really bad and a lot of it's really annoying. But actually, I think I've kind of got to the stage now where a lot of it's really highly personalized and tailored to me. I don't mind that much, as long as it's good. And I think we're at this horrible stage at the moment. We're in a kind of bad advertising phase because some of the data is just not quite good enough. And I think we'll eventually get to a stage where actually a lot of things will become so highly personalized, actually it'll become really valuable. I just think at the moment we're nowhere near that. And I think as it gets better, people will become more comfortable with it. But I know a lot of people disagree with me, and I'm sure a lot more people in this room find advertising annoying than I would be led to believe.
We'll give people a chance to attack you in just a moment.
Yeah.
Tim, you mentioned that you have these ontologies that are kind of essentially planograms for every property that you have. And this brings up, I suppose, an issue that a lot of people are concerned about as it relates to data, which is just security. Because now all of a sudden we have like potentially in data that you have to keep in order to run your business quite a lot of detail about some high-end properties. how do you assure people that you have an appropriate duty of care with all that data? What kind of links do you go to? How much time does that occupy? Where is that in your sort of pecking order of things that keep you up at night? That type of thing.
Yeah, I think interesting for us, like the trust factor is already gone. Like, as in, it's not gone, but people have to get over that hurdle because we're going to be in the home. And not only us, like other people are going to be in your home. And so they're trusting you with their second
Quite
most
a lot,
prized possession, right, after their kids. And so it's like, like we're over that hurdle. I think for us, the sanity thing is, yeah, we always worried about what happens if someone goes rogue and steals all the alarm codes for all the homes or something like that. And we had a lot of systems. So I mean, like a really good example is like each of our homes, got a couple of thousand homes in London. Multiply that by 6 sets of keys we had for each of those homes. That's a lot of keys. We started off having to deal with like casino style, like massive key rings, but we then had to develop some pretty sophisticated like security measures around that, which we can then apply to elsewhere. So we're going to detail on now.
All right, very cool. Well, we touched on kind of a thematic walk through some things that might have to do with ethics or how this is handled. But let's open it up to anything that you have in mind and get some questions. Yes.
Well, my question actually deals partially with ethics, because there's one area which the panel have totally ignored, and that is that we are likely to end up with a two-tier society: the rich who can afford all these things, and the poor who can't, or will have them imposed upon them, i.e. like these smart meters. When elderly people have these smart meters, that's fine. The meter reader doesn't turn up, so they've got nobody to talk to. It reduces their contact with the outside community. The example which was shown about the trolleys in supermarkets. Most elderly and disabled people do not use trolleys. So they're totally ignored. There's no information about them. And that is a massive amount of society. It's nearly a third of the consumers out there. And I'm not talking about the rich, I'm talking about the poor people. I mean, I've actually argued this point with Tesco's myself. And I have said, why do you put items up there on the top shelf, which are discounted, or on the bottom shelf, where somebody in a wheelchair can't get at them? And they say, well, that's our policy because, if you want a cheaper item, you bend down for it or reach up for it. And I said, yes, a disabled person sitting in a wheelchair, how do they do it? Oh, they can come and ask us. Okay, I said, let's see how that works, because my wife was in a wheelchair at that time. And she sat there, she went into Tesco's one day, and she sat there for nearly an hour, waiting for somebody to come and take her round for assistance. And then they didn't explain what was on that shelf. She said, what's the price of that? And they said what the price was, and she said, how much is that per pound? I don't know. They couldn't even calculate. They knew the weight of the thing, but they couldn't calculate it. So how are they going to help these people? So you're not actually creating a database. You're not helping them. You're actually, in a sense, making their life worse.
So how
As I say, you're separating them from society. You're separating them from people. It's an ethical issue as well as a social issue.
So does anybody think about this issue of whether or not using data to sort of tailor, whether it's advertising or product offerings or build new kinds of businesses and systems? Does that have an inherent kind of inequality bias in it?
I think so. It's a really good point, actually. It's like you've got to be really careful if you're going to be collecting data and using data that it is a representative sample set. And if it's not, then you are very much at risk of tailoring products. And but I think that's probably true of any data set and any research that you've done. But I don't know how you solve that. Yeah, it's a great point.
I think I'd probably challenge a bit the thing about the elderly, and that is a lot of the projects I'm seeing at the moment are about the elderly and the care of the elderly, especially helping the independent elderly because they're vulnerable, and often old people get land up in care homes simply because you can't have somebody there all the time. So various kinds of monitoring are now economic, and they help people, are looking like they will help people stay independent in their homes for longer. So I would challenge that to a certain
Well, no,
extent.
I understand that.
And
Perfect. But
hopefully the NHS will fund a lot of this stuff.
those are separated from people. They become machines, and they don't need so many people.
Again, I'd challenge that to a certain extent. And that's really more about implementation than about the intrinsic technology.
Oh, it's
Right,
not
and that is,
necessarily technology.
you can't afford to have somebody there the entire time, but if you've got a panic button that actually works properly and maybe can detect a fall, then you're in some situation allowing somebody to be independent, and it should free up resources to get visitors and things like that rather than moving into that. But that's about healthcare policy rather than technology. There's nothing intrinsic in the technology. This is the way those things are implemented. So, absolutely.
I have seen this actually in action.
Yeah, absolutely, I'm sure.
This system has been put in to a house, and the old lady in there has an automated meter reading and so on and so forth. She doesn't see anybody now. She sees one person who comes from social services once a month, and that's it. Otherwise, she doesn't see a single human being.
I've just been reading a book on introverts lately, and one thing that I think is helpful to keep in mind when it comes to this is that there are people who don't want that, and there are people who do. And I think one of the promises of all of this new technology is understanding which is which, and being able to respond in ways that don't spend that on everybody, but spend it on the people who matter. Next question.
So I got a quick question maybe for Elin and Michael, maybe Tim as well. So question is about putting a team together for as your enterprise in data science. Elin, you mentioned that the actual data science shouldn't take more than 20 to 25% of your time. So there's a huge amount of time spent not on data science. And Michael, you said that it's not enough to just put the best of breed of industry practices and best industry technology together and and think it works. You need to take an integrated approach. So how does, for example, Unify's team look like? What's the team composition if data science is actually not the core it's a core thing, but not the bulk of the work?
Unify is a pretty small team. And it's because the truth is there's actually a very small network of people doing IoT in the London area. So we kind of all know each other, and we're kind of recirculating around the other projects. But it's absolutely a problem. As I say, the trouble is that the problem is not that you can't find those individual skills. It's creating a holistic team that's got some reasonable appreciation about the entire end-to-end solution. In the IoT field, here's an example, and that is that you could say, well, here's data coming out of IoT stuff. Let's say it's a farm, right? About or livestock monitoring. We're looking at whether cows are sick or not, and we'll stick a data science team on the end. The real truth is, though, that actually what you want to be doing is doing part of the data science stuff actually down there on the cow where you're doing feature extraction rather than just sending endless temperature measurements. You're looking for things that are interesting. You're trying to extract features, and you have to design that so these devices can do that independently. So that requires actually somebody or some set of the team to be able to see the entire chain end to end rather than just trying to bolt things together blindly. Right, and I think that'll go for any of these things. It goes, in your industry with the hotel thing. It's very much that you have to get some appreciation of the entire chain through the entire team. And in the current small scale stuff that's happening, it's happening in a sort of lumpy fashion. But if you were trying to scale this out to bigger teams and in the way that it needs to happen if it's going to fulfill its potential, then there's a real lack at this point of that kind of experience. And I suspect that kind of education in the colleges and so forth, because there aren't people with that kind of industry experience teaching these things, and it's siloed, right?
I completely agree with Mike on that. I think the hardest role to hire for right now is a head of data science in a company that doesn't have a data science team, because that's what if you're a startup and you have a strong tech team, you can probably bring in a data scientist straight from academia who has the strong, at least programming and maths and stat skills, and make it work really well. If you have the strong tech team, they just get integrated into product. But if you're a large organization and you're trying to change the culture, change the databases and systems, and build a data science team all at the same time right now, it's really difficult. I mean, this is what we mean by data transformation. It isn't just doing a small project. A lot of, like, we were quite a small company. We're still 35 people with probably about 10 different skill sets, and any project could easily use up to 6 or 7 different people's skill set. And we're specialists. We specialize in data science and engineering. If you wanted a nice front end and wanted a good user experience and all this other stuff, you could probably make that number more like 15 people with different skill sets. So it is, like, lack of talent is one of the biggest constraints on this industry.
Thanks. So there's a standardish kind of process data scientists use when they're doing some analysis. So you look at the distribution of data in the data set, you clean it up, as you said, you drop the outliers. But because of the massive lack of data scientists, some of the tool vendors are bringing out smart data discovery tools that are alleged to do that automatically for you. Personally, I don't think that's possible without, or at least you run the risk of huge unintended consequences. As a result, I'd like your opinion on that.
I think it's really topical, because that is a lot of the companies who are coming out have what we call black boxes. Right? You put your thing in and you get this thing out. And if you're, or at least if I'm talking about my own book, obviously we want to believe that a tailored model that really understands both your business and your data will have better outcomes, and hopefully less biased ones, than one where they already have a black box and you're just putting your thing in. So from our side, our data platform is for conducting data scientists. It's like enabling data scientists to remove a lot of the engineering and security problems, rather than just lots and lots of black boxes for people to use. But that's our strategy. And I know a lot of other people have gone for a different strategy as well.
And just to put on that, I largely agree with you, because I think with data science, I don't know if you agree with this, but the hardest thing is knowing what question to ask, not necessarily getting to the answer. And I think that's the value which a good data scientist brings, is they know the kinds of questions and how to frame the question, which a machine just can't, well, which a black box tool set can't necessarily do for you, unless you're in a very homogenized industry, such as like e-commerce, and you're like, okay, here's the e-commerce questions that you end up asking. But if you're a relatively unique business, then it's much harder.
Is the next stage of advanced analytics how to use complexity theory, particularly intervention strategies, and understanding how boundaries change systems? And I'll give you an example of a boundary change. Rain, it impacts retailing, it impacts traffic flow, and it impacts distribution. Because all your examples are given you discrete examples. I think Tim got nearer to more a whole systems approach. And when you really get into intervention strategies, you find the laws of unintended consequences hit you between the eyes so quickly.
Can I say something on that? I would say that what we've heard so far is that actually it might be more of that than what you're seeing. I mean, I think Mike's story about seeing the end-to-end picture is just so that you can figure out where are the kind of interactions in a complicated system that argue for embedding some computation at the point of sensor, so that what you end up with is feature extraction rather than just sort of dumb telemetry that, you know, goes into some black box and gets kicked out in some way that doesn't make that much sense for you. But I would say, as true as that is, and I love that story, I buy that completely, it seems to me that it's not the next step. It's the next step, because people are going to have their hands full for a while just absorbing stuff that is done badly, mostly with buzzwords, and that's going to take a little while, longer than we might think is good. And there will be leaders that go way beyond that frontier very quickly, but the vast majority of what people are going to be implementing is going to be sort of bog standard stats for a while.
But to that point, I think that there is the predictive power of some of the neural networks, of things like recurrent neural networks, which means that we can feed all this messy, strange data, and we don't know quite how, but we can have something come out at the end that will predict that. Hopefully we don't, after 20 minutes, say, well, we know what that's going to do, and then take some action. What we do is look at that for a very extended period of time and say, well, we do seem to have a pretty good model, and we do know what it's going to do, and then we can rerun it with a different set of inputs and be reasonably confident that our intervention will do something. So there's at least the potential of being able to do something sensible about predicting the effect of our interventions and seeing what that does in these complex multivariate environments. But I think it's still research work rather than anything that I'd like to put my life on.
I think from like, especially marketing is a good case in point. Like people often come to us and expect you build this model, and now I know exactly which customer is going to buy, what way to speak to them, when to speak to them, what they will buy, and therefore I can sort out my whole system. And that's just not how it works. Actually, you maybe have an algorithm, it makes predictions, but you need to test it, and then you need to continuously test it. And actually, the way I suppose marketing is you can't distinguishing between different effects of marketing, multi-attribution marketing, all of this stuff is still not figured out at all. And so you have to run tons and tons of tests. And the data science helps you, or at least it helps with directions, but it doesn't actually, in certain situations, it doesn't solve everything for you. The stuff that's really nice and clean and make good case studies is because there's a lot of data that's already been collected, it's well collected, it's clean enough to use, and you can start, especially in the world of business, if you can solve most of the problem by implementing what you have, making that extra 2 to 5% isn't worth it. But it doesn't mean that you've already cracked all of the problems using some of the case studies I've suggested.
Yeah. I think that's absolutely right. There's a lot of quite narrow cases. I think marketing is at exactly that point, that attribution. Now, it's just so difficult to do, and we're constantly being asked to add in more data points, like more data will actually get us to the answer. And the reality is actually, a lot of the time now, we're reducing the number of data points we're using because the spread, we're just not learning anything. It's just too complex. So we're actually going down to what can we learn in very more specific instances and focusing on that rather than trying to throw everything into the pot and hoping for the best.
I'm not sure how we should do this. How about that? Yeah.
Make them run around a bit.
Hi, so I am a marketer, so I'm kind of working at the slightly more prosaic end of the spectrum, if you like, but I've always found myself actually in my last 2 companies being the one who set up the analytics team because I just can't work anymore without some sort of data science or analytics team. So my question for each of you is, what advice would you give me as you know, a chief marketing officer trying to use data science as effectively as possible?
I'd probably say, to your point just a second ago, is probably try and keep it as simple as possible and then build from there. If you try and overcomplicate it, you try to use too much data, or you try and be too ambitious too soon. It's the same as building any function. Just like get the proof point, prove that you can implement it in the rest of the business, get buy-in from the rest of the business, and build from there. And just be super simple. Like do A/B tests. That's effectively data-driven like tests as well. Like you don't necessarily have to go to like crazy genetic algorithms.
No, not like MVT or anything.
Just build from there and just always move from there and then prove the value, get a bigger budget.
I totally agree with Tim on that. It is I think the danger of stuff, especially like multi-channel attribution and using all these channels that you don't understand and don't know, is that you actually end up maybe biasing the stuff that you do have. And kind of bias is like breaking it down and understanding the biases. Even something like, maybe this is more detail oriented, but like a channel might have this ROI, but actually these different components within the channel, there may be stuff that is missing. So it kind of depends, I think like really understanding your data and then doing the best what you have and testing like crazy.
I think we also find the most important thing is actually knowing what's really important to measure. What's actually really, because you can measure almost everything now, but actually what's actually really important to your business? What are the real assumptions that drive your business? What are those key performance indicators? And being really, really clear on those, and then going back to, do I actually have the technology now in place in my company, in your company, to go, actually I can measure those things. And I think if you don't really know what you need to measure, and you don't know if it's really going to drive your business, then I think we come across this all the time. People are like, I want to measure everything. And it's like, actually what's really valuable? There's only often 1 or 2 metrics in a lot of these campaigns that make a difference. So be really clear on what you want to measure and make sure you've got the tech in place. And if you don't have those 2 things, then you'll be stuck.
How much agreement is there on when IoT data becomes personal data and therefore under the Data Protection Act? Is that sort of universally agreed across the industry? Because obviously if it comes under the DPA and soon the GDPR, then the potential fines for getting it wrong are a bit more serious than just whether or not you're being ethical.
Yep. And I think that there's almost certainly not enough thought being given to that. As I understand it, and I suspect you know much more about this than I do, the Data Protection Act was really designed in a time where we were thinking about people's names and addresses and bank account numbers, whereas the actual wording, I suspect, is something about being able to identify people in various ways. I've got a company I work with, and they're perfectly ethical, and there's a very reasonable way of doing these, but they're doing people tracking by people's shoes. That might actually come under the Act, which is, I hadn't even thought about, I have to say.
And even your location tracking, you go in and out of your house every day, so it's obvious who it is.
Beyond any doubt. I think there's 2 points, and one is about making, it's again, the legal position is one, and we should be aware of that, but that's why making sure there's an ethical code of conduct, which is built into the DNA of a company, kind of keeps you safe. As in, regardless of the legal position, do what's right.